Lesson number 54, polar coordinates and similar triangles. So we're on page 233-ish. At this point in your wonderful young lives, you have learned to do all of your work on the graph that you see up there. Anybody want to give me a good name for what this thing's called?
XY axis.
XY axis. What else is it called?
The polar coordinate plane.
Coordinate plane. Also called the Cartesian plane. And one of the other phrases, as you say coordinate plane, it's actually called the rectangular coordinate plane or rectangular axis. So what we're going to do today is we're going to talk about, because it is a little bit wintry outside, we're going to talk about polar coordinates. Okay. So at this point in your career, you have learned to determine where to place a point on the graph based on which way you went, left or right, and which direction you went, up or down. So what we're going to do is we're going to make a little bit of a change in how we verbalize that or show that bit of information. Right now, that point, if you were to tell me what that point is, you would go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. That's the coordinates for that point. What we're going to do now is we're going to make a little bit of a change on how you write 7, 3. Okay? We're going to write it as 7 to the right plus 3 up. Okay? Depends on the book. They will use different letters rather than R and U for right and up. Some books will use 7I plus 3J. So they use I as your x-axis and J as your y-axis. But, Madison?
You could get that confused.
With what?
Imaginary.
Imaginary numbers. So that's why this book does not use I and J. Let's say I've got a point that's over here. We do not use 7L. Okay, for 7 to the left. What we're going to do is we're going to go 1, 2, 3, 4, 5. We're going 5 to the right, but we're going 5 in the opposite direction. So we're going to call it negative 5R.
We're not going to do it.
Plus 2U. And you do the same thing when you're down here. So we're at negative 4R minus 1, 2, 3, 4, 4U. So for the most part, all we're doing is we're putting what direction, left or right, we're going. Actually, we're really graphing negative 4, negative 4. We're just putting an R and a U after the 4s. And up here, this was 7, 3. We just put an R and a U after them. Okay, so not really that hard, not really that confusing, and not really polar coordinates. So that is just another way in this section they're writing rectangular coordinates, is 7R plus 3U. Okay? One of the things that we need to know in order to find a point, we need to know the x value, we need to know the y value. But if we knew, let me draw one here. If we knew this angle, and if we knew the length of that line, we would also get to the same place, right? Because we're taking this line and we're moving it up to, let's say, 30 degrees, and then we're drawing at that line. So we are given 2 bits of information, 2 coordinates, but instead of a right and left, up and down, we're giving an angle and how long that hypotenuse is. And this is a key thing in graphing. I don't know if I've talked about this yet, but I'm going to now just real briefly. When you are drawing a triangle, which those of you guys that are brave enough to take college trig next year, which I hope is a bunch of you, one of the most important things about trig is you're dealing with triangles all the time, and your hypotenuse will always be a line that comes off of the origin. Okay? It will always come off of the origin and not be your x or y axis. So whenever you're drawing it in, some students have a tendency to do this, is they will draw a triangle like that on there and try to make decisions based on that triangle. Well, you can't, because the hypotenuse, neither one of those endpoints are off of the origin, so that doesn't work. The hypotenuse must always come off the origin. All right, so when they give you a length, they're always giving you the length of the hypotenuse, and when they're giving you an angle, they're always giving you the angle at the origin. This length here is called the line's magnitude. So what you need is you need magnitude and you need direction.
Direction?
And when you have magnitude and direction, you have what's called a vector.
We learned that from Despicable Me.
You learn what?
I learned that.
You want to see that video
Despicable
clip?
Me.
Yes, please. Yes.
With both direction and magnitude.
Oh, I didn't watch
yeah.
Despicable Me. I'm talking about 1980, the movie called Airplane.
Oh,
Let's watch
it.
that.
Oh.
What's
I
that?
just watched that like 2 days ago.
It's a good
No,
one.
I don't know what that is. Don't forget
Okay.
to pause it.
No, don't pause it. Don't pause
We
it.
have to.
Okay, so couple things that you need to know about these vectors, Victor. Every single angle that you use to determine where a point is has to have as one of its sides the x-axis. So for instance, this one right here, I need to know what angle that is. If my line that I was looking at the angle, let's say it was over here, the angle that I'm looking at is this angle. Okay? It's not this angle, not this angle, it's just this one right there. Okay? So we're looking at angles that are smaller than 90 degrees.
Acute angles.
Okay, yes, we're only looking at the good looking angles. All right, so if this length here was 8 and this angle here was 30 degrees, the way that we would write that, instead of 5u plus 3, 5r plus 3u, or the point 53, we label that as 8 at 30 degrees. So that's what it's going to look like.
Looks like 8 is less than 30 degrees.
Or
It kinda
acute angle,
does.
30 degrees.
Okay, actually their little angle thing goes a little bit further than mine, but I don't write it that way. Okay, so that's what it's going to look like. All right, so during this lesson, we're going to talk about how to convert from polar coordinate system to rectangular coordinate system. So if I give you an angle such as 4 at 57 degrees. So I give you that information. That means I have an angle that is, I'm sorry for my cough, 57 degrees, and it's 4 long. All right, so this is 57, and my hypotenuse is 4. And what I'm trying to do, if I'm going to change this into the rectangular coordinate system, I need 2 coordinates, like 5, 2, 6, 7, my x coordinate and my y coordinate. So that means that actually what I'm going to end up doing is making a triangle. And what I'm going to do is look for my x and look for my y so that I get that point right there. Anybody have any suggestions how I might go about doing that?
You have to find the sign of 57 and equals M.
Okay, I'm going to go through the theory following what direction Tommy went. Sine of 57 degrees equals opposite over hypotenuse. Okay? Then I take 4 times the sine of 57 degrees, and that equals y. And you guys have here, you guys understand this, that 4 sine of 57 degrees means 4 times whatever the sine of 57 degrees is?
Yeah.
Okay. That's all we're doing. Taking the sine of 57 degrees, Kendra, and multiplying it by 4. I saw you had a calculator, so I'm just waiting.
3.35.
Yeah.
3.35? Okay, so 3.35 equals y. How do I find my x value? I can do Pythagorean,
I'd rather
yes.
not, since it's a decimal.
I could also use trig, and it would be sine, cosine, or tangent. So cosine of 57 degrees equals adjacent over 4. So 4 times the cosine of 57 degrees equals x. So what is my x value?
2.17.
All right.
2.18.
So my x value is 2.18-ish. So that's that point. If I were to write it in the form that I did with the r and the u, I would go 2.18r plus 3.35u, call it good, and go home. Okay? So that's how you change it. Now, if you do enough of these, you start finding a pattern. And that pattern is, see if you agree with this, that your y-coordinate equals your hypotenuse times the sine of theta. Have we talked about theta at all?
No.
Oh! Don't get too excited here, guys. Theta, spelled T-H-E-T-A, is this Greek letter, a circle with a line through it.
It's an egg. It's an egg with its head.
The letter theta represents the degree of the unknown angle.
That kind of works.
So it's kind of like finding x. You know, x represents a number that you haven't found yet. Well, theta represents an angle you haven't found. So it's just a way to say, what I'm looking for here is an angle, but we don't know what it is, so instead we're not going to call it angle x, we're going to call it theta. So anyway, that's what that means. So y equals whatever the hypotenuse is times this angle. Because remember, if we went back up here when we were looking for y, here we go, 4 times the sine of 57 equals y. So I can say that whatever length, whatever my magnitude is, if I multiply it by my angle, whatever it is, in this case it's 57, we find y.
So we'll always get y, but we don't know x.
Well, let's see. What kind of formula did you figure out using this stuff down here?
4 times cosine.
Mm-hmm.
Oh.
Your hypotenuse times the cosine of theta will give you your x value. So whatever angle I give you, you're going to put that in for theta, multiply it by your hypotenuse, and you've got your value.
There's such a thing as a theta sign on the calculator.
There's no sign. You do have a theta on your calculator. You should. I mean, most of exciting things to do as we continue lesson 54. Similar triangles, page 235. We were going to draw some similar triangles here just because they are just so much fun.
The cheeky.
All right, we're going to call this a And we'll call this B, and this C, and this D. And I'm going to tell you that that angle and that angle are the same. And by telling you that those two angles are the same, and since you know in your extremely genius little heads that those angles are the same, you know that all three angles are the same measurement. Okay? Angle means angle. Okay. So knowing that that's true, what can we say about those two triangles? Thank you. Are they congruent?
Equiangle.
Not necessarily, but we do know that they're similar because the angles are the same. So similar triangles have a relationship, a proportional relationship here. So my proportions are C is to A as
D is to B.
As
B is
D is to B. So C is to A as D is to B. Okay. Now notice we pick C as the top one that's across from that triangle or that angle, and we picked D because it's across. Okay, so therefore I know that my C's are on, and C and D are on top, which means my A and B are similar to each other on the bottom. You got to make sure that that's true. You can't look at one side here and compare it with another side that's not similar. They have to be similar to similar. Okay? I could write it as A to C equals B to D as well. Doesn't really matter one way or the other. Erica, is that what you're going to ask, or are you going to throw up?
No.
Okay.
I just hit under a
Oh,
bar.
you just had a pained look on your
It's the
face.
weirdest thing. No, my hands are.
Okay, so if that's the case, then I ask you to
The polarity though.
solve for D. Okay, algebraically, one of the things that you'll learn real quick is you don't always have to have numbers to do math. You can use letters. I mean, there are times where we'll spend the whole day in calculus and have the whole board filled up with stuff and there's no numbers up there. It's all letters and Greek symbols and other weird stuff. So, math isn't just designated numbers. It's symbols of quantities and stuff. So, that being the case, and we're looking for D, how are we going to solve for D given this equation? Any ideas? Cross multiply. So BC equals AD. Okay? If you have an equal sign, you can cross multiply, and most of the time this is going to help you out. Tommy, what were you saying? Divide by A. That goes away, and we have D equals BC over A. If those were numbers that I had filled in there, you'd come up with a numerical answer rather than BC over A. Yeah, not too hard. Okay,
Next lesson.
that's it.
I'll ask you.